Mechanics, Newton's first law of motion. Okay, an object at rest will stay at rest. So let's have a look at an example that demonstrates this. So we have a car. Its weight is 9,800 newtons. Weight always acts vertically downwards on a diagram. Now the road here is pushing back up on the car, so the normal reaction force is exactly the same in magnitude but in the opposite direction, and it's always perpendicular to the road, to a surface. So if the road was inclined like this, the way it's still acting vertically downwards, but this force, the normal reaction force, is perpendicular to the road. But we're not looking at this, we're looking at this example. So the car is at rest. The upward and downward forces, the vertical forces, are balanced. So resolving forces vertically and taking the upwards direction as positive, we have 9,800 minus 9,800, which is 0 newtons. The resultant force is 0. So the car which is at rest remains at rest because the resultant force is 0, which is the first part of Newton's law. An object at rest will stay at rest. An object moving with constant velocity will continue to move with constant velocity. So let's have a look at an example on this. So this time the car is moving towards the right with a constant velocity of 5 meters per second. The vertical force is acting on the car in balance. The car's engine is producing a thrust force of 100 newtons towards the right, and there's a frictional force between the tires and the road of 100 newtons acting in the opposite direction to motion. So resolving forces vertically, 0 newtons, forces are balanced. Resolving forces horizontally, 0 newtons, the forces are balanced. So the resultant force is 0 newtons. So if the forces are balanced, so if the resultant force on the car is 0 newtons, that means the car will continue to move with constant velocity. It continues to move at 5 meters per second. So this is true that the object will be either moving with constant velocity, or if it's at rest it will remain at rest, so long as the resultant force is 0. Now if an unbalanced force acts on the object, that means the resultant force is no longer 0. So in this example we have balanced vertical forces, but horizontally there's a 500 Newton force acting to the right and 50 newtons to the left. So balanced vertical forces and then resolving forces horizontally gives a net force of 450 newtons to the right. That's the resultant force there, which means the motion of the car will now change. We will get some acceleration. If the car was stationary, it's no longer stationary. If it was moving with constant velocity, it's no longer constant velocity, because that's what Newton's law states here. It says unless an unbalanced force acts on the object. And if there is an unbalanced force, which is what we have here, then you will no longer have the car being at rest or the car moving with constant velocity. So this was the outcome. Here is another similar example demonstrating unbalanced forces. Again, the vertical forces are balanced. Horizontally, if I take forces to the right as positive, so we'll have 60 minus 200. So now the resultant force will be 140 newtons, but the minus is telling us it's in the opposite direction to the arrow here. So it's 140 newtons towards the left, like this. So this could be an example of a car that's in reverse gear and it's going backwards. Example 1. This particle is stationary and the forces on the particle are balanced. All the forces are in equilibrium. The resultant force is 0. So looking at forces horizontally, so resolving horizontally, so we have 5 minus t, and that should be equal to 0. so T is equal to 5 newtons. Resolving forces vertically, so 8 minus W will be equal to 0. So W is equal to 8 newtons. Example 2. This particle is moving with constant velocity, so the resultant force on it will be 0 newtons. So taking the upwards direction as positive, resolving forces vertically, we will have 55 minus 3t minus 2k is equal to 0. And resolving forces horizontally, we will have k plus t minus 20 equals 0. And then solving these simultaneous equations, we get t equals 15 newtons and k equals 5 newtons. Okay, example 3, we have a stationary block here, and it's held by these two ropes. Okay, so we can draw a diagram representing this situation. Okay, so the weight is not 100. Yeah, this is the mass. We have to use a simple formula to work out the weight. It's m times g, where g is 9.8 meters per second squared. So that gives us 980 newtons for the weight. So if we resolve forces vertically, so T plus T minus W is equal to 0, because the block is stationary and the forces will be balanced. So we have this. So T is equal to 490 newtons. There is a tension force in each of these ropes of 490 newtons. For practice, try these questions.